In this segment we're going to talk about addition, and this time we're talking about addition of mixed fractions or improper fractions. So the first question we're going to look at is 1 1/4 plus 1 1/4. I've chosen this because it's relatively small numbers and they start off with common denominators, and in our next example we'll have different denominators, and we're going to not have to worry any about regrouping going on in this first one, just to make sure we understand how to do the improper fraction. So here's how we would model that. Our double pink is a whole. So here's one whole. So there's our 1. And we have 1 out of the 4 pieces. So 1 whole and 1/4. And we're going to add to that another 1 whole plus 1/4. Now there's a couple different things we can do even with this diagram the way it is. Some teachers like saying, okay, well, we all have the same shape here, so we should be able to add them all up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 quarters. And so we get our equals 10 quarters. But 10 quarters is an improper fraction, and now we have to change that into a mixed number. And some people go 10 divided by 4. We've talked about this. There's lots of different ways of changing an improper fraction to a mixed. 10 divided by 4 gives me the answer of 2 with a remainder of 2. And so 10 divided by 2 gives us 2, remainder 2. But it's 2 what? Well, it's 2/4, so we could write that 2 as 2/4. So it would look like that. And then 2/4 can be reduced to 1/2. So it would look like that. And that technique works. And if the numbers are small, this will work. I'm not a big fan of this technique though, and I'll tell you why. When we're working with fractions, we're often using measuring, and often I'll get a question, let's say if we're cutting a piece of wood and I want to cut it 27 1/8. And then I want to add to that another piece that's 3 1/8. So our question might look like this. I don't want to have to go 8 times 27 to get 100 and something plus 1, and then add 3 times 8 is 24, 25/8, and I have 100 something plus 25 something. I'm stuck having my calculator and working out all sorts of difficult pieces, as opposed to 27 plus 3 is 30, and 1/8 plus 1/8 is 2/8, so my answer is 30 and 2/8. I think that's a much more realistic way of doing it. It's a much more common and practical way of doing it. As long as our numbers are really small like this changing it to an improper fraction works. It wouldn't be a bad idea to show a student that, but I certainly wouldn't want to be the way that they go to. So I want to show how to do it in a different way, leaving the mixed fractions the way they are. So going back to my picture, I've got 1 and 1/4 plus 1 and 1/4. This piece here I can move over. It's 1 whole. So I've taken my wholes, put them together. So there's 1 whole plus another 1 whole gives me 2 wholes. And so I can show that up here. And here's my 1 whole plus my 1 whole giving me 2 wholes. Here's my 1 whole plus 1 whole giving me my 2 wholes. Now I'm left with this piece over here. And we've dealt with this before. I've got 1/4 plus another 1/4 gives me a total of 2 quarters. And if I want, I can take this 1/4 and flip it around so that we can see that 2 quarters is the same thing as 1/2. So now I've got my 2 wholes plus 1/2, and I get the same answer, 2 and 1/2. And if I was doing this question with my cues and air rods, my pink or purple is a 4 block, so 1, 2, 3, 4. So there's 1 whole plus 1/4. There's another whole plus 1/4. And together, that's going to give me 2 wholes. There they are. There's my 2 wholes. Plus I have my 1/4 plus 1/4. They're the same kinds of things, so I'm adding them together. That's going to give me 2 quarters. So my answer is going to come out to 2 wholes plus 2 quarters. And so there's our 2 and 2 quarters, and our answer is 2 and 2 quarters. But our 2 quarters can be reduced, and I can show reducing using my magic 1. And there's my magic 1. Dividing by 2 over 2, which is my magic 1, gives me 1/2. So my answer could be, instead of 2 and 2 quarters, it could be 2 and 1/2. And there it is there. My 2 wholes and my 1/2. And just showing that my 1/2 can be written, and where my dividing by 2 over 2 comes from. And visually showing that, my 4 block is made up of 2 2's. If I take this one and put it on that one, and I put this one on that one, I've cut it into 2 equal sized pieces, and that's the same thing as 1/2. So 2 out of my 4 is the same thing as 1 out of a 2. So it's relative, it's proportional, and that's another way of showing how my magic 1 works using the Cuisenaire rods. And using the array model, we're going to show 1 1/4. So here's my 1 whole, and I've divided this up into quarters, plus my 1 1/4, and I'll shade those in. And I can see I have 1 whole square and another whole square. That gives me 2 whole squares. And this quarter I can shift up here for a total of 2 whole squares and half of a square, or 2 quarters. And we've talked about already that 2 quarters can be reduced to 1/2. So I get 2 1/2 using this array pictorial model. And on this question we're going to go 1 3/4 plus 1 2/3, which is going to have different denominators, and we're going to have some carrying that we're going to have to deal with. So we have our picture representation, or our manipulative representation of that. I've got 1 whole plus 1 2 3/4, and over here I've got 1 whole plus 1/3 and another third. So 1 3/4 plus 1 2/3. Now my wholes are the same shape, so I can add those together. So I'm just going to recolor them so we can see what we're going to add together. So we can see now that they're both the same, so we can add these two pieces together, and that's going to give me 2 wholes. So 1 plus 1 is going to give me my 2 wholes. And there it is there, or I can put it up here maybe. That gives me my 2 wholes. Now I have to deal with all my pieces over here. They're not the same shapes. These are not the same shapes, so I can't add them, and we've talked about this before. Is there a shape that we can make all of these shapes, the blacks and the reds, out of? And the answer is yes. We can make them out of our green triangles, which are 12ths. So we're going to do that. And so I've changed them all into these green triangles, which are 12ths, because it takes 12 triangles to fill up one of our double pinks. And so I have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. I've got 17 12ths. So I could write it like this. And I can see that that's an improper fraction, so I can make 1 whole, and I'll have 5 left over. So now what I have to do is I have to combine my 2 wholes plus my 1 5/12 to get my answer. So 2 plus 1 5/12 gives me a total of 3 wholes, 1, 2, 3 wholes, and the 5/12 that I have left over. By keeping the numbers as mixed fractions, I'm only working with 12ths, and I'm not working with anything too high. 17/12 is the biggest I'm going to have. If I had to change these numbers, my numbers get very large very quickly, and I'm stuck having to use the calculator.